All right, Kayla.
Yep. Hang on, we're going live. Give it a sec. Hi, everyone. Welcome to today's webinar on cloud modernisation. My name is Kayla Elise and I'm the marketing manager for MOQdigital, and I'll be your moderator today. With me today, I have Piers Matthews, our CTO, Michael Youssef, one of our solution architects, and we're also joined by Adam Stevenson, an Azure specialist from Microsoft. The Q&A is open on the left side of your, the right side of your screen. So if you'd like to ask any questions, we will answer them towards the end of the presentation. I will hand over now to Adam to get us started.
Hi,
thanks, Kayla.
Yeah, go ahead, Adam.
I know so hi everyone, thanks for joining in today. I'm Adam Stevenson. I'm a application development specialist at Microsoft, and so my job really is working with our large enterprise and government customers to ensure they're successful. And I do that by pulling in a wide range of different Microsoft architectural and technical resources. And one of the keys to our customer success is bringing in the right partners, and that's why it's great here to be here today with the team from MOQ, who we work with a lot around the modern application development and integration and application modernisation workloads. And we work with them a lot. We see there's a really large uptick in developers and infrastructure teams using our more modern cloud native and serverless components at the moment. We're used to, especially in the large enterprises and government agencies, I see all the time, there's a lot of legacy structure around, but modernisation is happening everywhere. We don't think of government and large enterprises necessarily leading the charge on being modern and new technologies, but even in those organisations today, application modernisation is happening en masse. It really is today. It's not an if, but when for most of our customers is when they come around to application modernisation, and we're investing in this a lot. We're investing it in our toolings and in our platform, and also in our partners. And we see that really working with getting a good partner in to show customers the way to modernize is really where, as Microsoft, we see a lot of success happening. And MOQdigital have prepared some really interesting overviews and insights today, and I'm really looking forward to having them share those with you.
Thank you very much, Adam, for that introduction. So my name is Piers Matthews, CTO for MOQdigital. So the scope of what we really want to cover today with you guys is this idea that talks about what is cloud native and serverless. We're going to demonstrate some of that to you. We're going to talk about an overview about how you can do modernization in towards those technology stacks. And then joining me is Michael Youssef, who's going to be driving the demos, and we're going to actually show you how some of this technology fits together. So what do we know about cloud native? Cloud native is considered the new paradigm of how we choose to build software moving forward. What we know is that IDC specifically says by 2022, we're looking at 35% of all applications will be built on the cloud native platform. So certainly the analysts are saying it's definitely something we should start paying attention to. When we think about cloud native, it's important to get a definite definition. As a technologist, I always like to have a good definition for things, and the Cloud Native Computing Foundation provides us that definition. So the Cloud Native Computing Foundation is essentially not profit. It provides a place where all the large vendors come and collaborate about what it means to be cloud native, and this is their definition. Lots of complex words. I'm going to try to simplify it into really a couple of bullet points that really explain what cloud native actually is. So cloud native means the ability for us to run highly scalable applications in a dynamic fashion in both public and hybrid clouds. We want to have coded infrastructure, so we shouldn't be building our infrastructure manually. Our infrastructure should be deployed as code. Our solution should be resilient and manageable and observable, which means they'll be able to, if something fails, it should almost automatically self-heal. It should be easy to manage, and you should easily be able to watch what's going on. And most importantly, To be cloud native in terms of your solution, it means we have robust automation, not just at the infrastructure piece, but also the application piece and everything that wraps around it. That's really what cloud native embodies and what it tries to do. Cloud native is not prescriptive about using Kubernetes or serverless technologies, although these certainly help you to become cloud native in terms of what those technologies espouse to provide us with. So zoning in on that a little bit more, when we talk about cloud native, it's really about packaging your application code, all its dependencies into containers or into serverless functions, and deploying those things as microservices and managing it through Microsoft's DevOps tools and processes. And the reason this is important is really what we're trying to do is compartmentalize applications and make it easy to roll them out. When we look at cloud native applications and solutions, there's really 4 key things we look to represent what they are. The first thing is APIs. So when we build a cloud native application, we always want to be building or having that APIs around that application. And why do we want APIs? Is because it means it's easy to compose or decompose that application and make it consumable to multiple front ends or consumers of that application, really standardizing how we interact. Containers or serverless functions, these really provide a way that we can wrap up the functionality that our applications have in an easily deployable, completely repeatable pattern. It abstracts the code from the underlying infrastructure differences and really provides us one of the most efficient ways at the lowest cost to run our applications. DevOps in terms of cloud native, this is all about people, process, and technology in collaboration, making sure we can build and deliver in a continuous cycle into our environment. So turning on tools that allow us to do it. And lastly, one of the key things about being fully cloud native is start to adopt modern architecture. So what is modern architecture? We talk about decomposing our applications into little microservices. A simple example may be, I might have a big application landscape that has repeatable need to do ratings of a customer experience. Instead of having a rating service kind of bundled up into this monolithic application, I create a single microservice, and his only job is to deal with receiving ratings for customers, performing aggregations. So a very domain-specific service that is completely decoupled that I can compose with other microservices to build out my full landscape. So that's what cloud native really means. The idea here, it should be able to allow us to move fast. So that's some technical speak. What are some of the business benefits that we might get out of cloud native? So while we want to be cloud native, is really 3 main areas. The first is speed of innovation. When we have cloud native, we're able to deploy quickly, we're able to change quickly, we're able to be more innovative. Cloud native means you also get to take advantage of some of those cloud services that we have. Reliability. Reliability is all about making sure our applications scale, we get 999 redundancy, these things don't fall over, and essentially they enhance our brand and reputation as we build these applications. And last thing, security. What we want to have is enterprise-grade security at all levels of the solutions that we deploy into a cloud-native architecture. So if you look at where Microsoft lands in terms of that capability, really there's a couple of things. So the first thing, Microsoft has an excellent developer experience, probably the best developer experience, certainly as noted by Forrester. It's extensive, complete tool chain from Git all the way to production. What that means is all the tools I need are available from Microsoft to allow me to take my solution from the source code environment being Git all the way into production. Next, we have serverless scaling with no infrastructure to manage. So one of the key things over here is we don't want our IT operations folks having to manage too much infrastructure. We want to avoid having to manage virtual machines. We want the solution to scale automatically based on load and based on dependencies without us having to manage too much of the underlying work. Reliability. So if you look at in Azure, beyond all the Kubernetes services and the serverless functions, we start to look at some of the other PaaS services. So a great example of this is Azure SQL, which is a fully managed database service, platform as a service that provides us high reliability, single-digit latencies in terms of reading and writing, and it's available in more regions than any other cloud providers. So we're able to distribute that accordingly. And lastly, security at scale. Microsoft makes a massive investment in terms of security in what we can do in our cloud native and serverless environments. We have $1 billion worth of investment around that every year, and we have the most compliant certifications attached to those Microsoft data centers and into the solutions. What's great for us as developers, when we start to work with some of this code and this capability, we notice that we get out-of-the-box integration with the Azure Policy Manager, Active Directory, as well as Security Center and Sentinel, which means that's very easy for us to essentially turn on security as opposed to having to code up that security, which means that obviously we can move faster, we can be more innovative. So that's great, you might be thinking. Piers, you've told us a whole bunch of fancy stuff about cloud native and these amazing things we can do if we build microservices and we have containers and we have serverless and we expose things through APIs. What about modernization? Because not all applications are ready to go directly into that mode. They're not really there. But what about modernization? So certainly modernization is something we will want to be able to do. The first thing is we need a reason to modernize in the first place. So most people who have solutions or applications already probably know there's a good idea to keep your application up to date and to modernize it, but there's some key drivers. When we start to move off a traditional infrastructure or traditional application architecture and slowly move up the chain into the cloud architecture or cloud native architecture, we notice that we get at least 80% reduction in administration of that actual application infrastructure and the things behind it. We start to remove all the patching and the complicated networking and firewall configurations that have to repeatedly happen. We're able to make changes to our application and deploy that application changes quickly. So we have a massive reduction in administration. If you look at websites, as a way of example, the type of application may be a website, we can get new websites deployed into environments and updates to those websites up and running in minutes. We can have those servers available behind the scenes that we don't even know are there, up and ready and running. We don't have to wait for that. And what this means for us is, as engineers, we're able to improve our application development delivery time. Lastly, data analysis. One of the great things about cloud is scale, and not just scale allowing us to scale our applications, but also to scale the type of data we collect and we analyze and we use. So cloud scale data allows us essentially to collect additional information and to start to understand the usage of the solutions that we build better, and then obviously improve those solutions, but also have a better understanding of our customers, suppliers, partners, and even internal employees who are using our applications, so we can start to personalize those applications and to use that data a little bit more intelligently. In short, modernizing applications toward the clouds is a good idea. The challenge is you don't just start in a massively cloud native application. So this is what I call the app modernization continuum. And generally what we find when we want to modernize our applications, we can go all the way to the top right, which is really our most innovative type solution, and always start at the bottom. Our most innovative type solution is a completely rebuilt cloud native ground up greenfields implementation, where maybe we take some data and a little bit of code, but most of what we're doing is rebuilding over there. This one obviously takes the most effort and cost and takes the most amount of time to migrate, because you're essentially building your application to take full advantage of everything that the cloud has to offer. Typically, when we look at modernizing in that approach, we'd look at saying, what is the customer trying to do? What are we changing about our application? So this is typically an outside force that says, we need to be more innovative. We need to do these specific things. And that's when we look to rebuild. At the bottom over here, really the lowest tier is what we call a rehost. So you might have heard of the lift and shift concept. This is the idea of infrastructure as service. So where you take an application that runs in VMs and essentially you lift those VM workloads and you put them into the cloud and you run them. Nothing wrong with that, but it's not really that different from running your local data center, other than Microsoft provides that automatic provisioning so we can get those VMs available to us much quicker. The difference here, really, what we want to be trying to do when we move our applications to the cloud is somewhere between refactor and re-architect. What refactor talks about is the idea that says, okay, I don't want to take my entire application and leave it as is and run it on VMs. What I'd like to do is to see if it's possible if we take some of my application components and host them in platform as a service. That way, Microsoft takes care of all of the underlying infrastructure components, and really I'm just worried about managing that application. So refactor is about rehosting in PaaS services. Re-architect says, how can I look at changing the architecture of my application? Are there certain services it provides or certain capabilities where I can remodel some of those capabilities into pure serverless or into container-based workloads. So that's when we start to look at re-architect. And generally, when we start that modernization journey, we're going to be in one of these areas over here. Most customers, we end up working on a refactor re-architecture approach, which allows us to provide enhanced performance and benefits and release timeframes and all those good things at a lower cost than just hosting on VMs. So certainly, as we move to the cloud, we have these options. We then go into a little bit more technical stuff maybe. If we think about Azure solutions by application type, really when you have applications, there's a couple of different types. The first type of application we might have heard about is a monolithic architecture. So for example, a monolithic web application where everything's sort of bundled together in one code base. It's deployed and run as a single unit. These types of applications are best fit to look to move. Yes, you can obviously put them in VMs, but what we want to try to do is move them into Azure App Services, which is a platform as a service specifically designed to allow us to run these monolithic applications in a platform-friendly way. We can also consider to move those applications into Azure Kubernetes services, although if it's only a single application that you're looking to modernize, there's not necessarily much point in spinning up a full Kubernetes cluster for that. An app service is fine. We then get these applications called end-tier applications. So for those in the calls who aren't technical or in the developer space, end-tier applications, you might have heard the devs talk about our front end, our business tier, and our data tier. That's your typical end-tier application where you've got a front end, you've got some services in the middle, and you've got a database tier. These applications, again, are fantastic to move into Azure App Services, that platform as a service capability for us. But more importantly, if we have a large application portfolio, we've got a lot of applications using this sort of common end-tier architecture, that's where Azure Kubernetes Services starts to make sense because we can do that at lower cost accordingly. Finally, we have these cloud-native microservices architectures. So this is when you're either greenfielding an application or you've already started to build an application that microservice way. The recommended approach here is to move either into Azure Kubernetes services, so that's that AKS environment that runs our application in as microservices and containers, or into Azure Functions. So Azure Functions is completely serverless solution, very good for an event-based model. An event-based model is something along the lines of somebody submits a rating. When that rating is submitted, I may want any number of processes to kick off. So I have a whole bunch of these Azure functions which realize there's been a new event that's raised and they kick off and they do the task. So they email the marketing team or they go and update an average or something to that effect. So that's when we start to use Azure functions. So this is really just giving you a quick smattering of the fact that we can take any of these applications and look to modernize them. And we don't have to start with virtual machines. We certainly, even on these monolithic applications, have the opportunity to at least modernize in that refactor approach for ourselves. There are three key components I want to talk to you about that live inside of Azure before we crack onto Michael's technical demo. And these components, if you remember anything out of this webinar, these are the three components I'd like you to understand and know about because they add so much value in terms of our modern cloud architecture. The first of these components is Azure Kubernetes Service. So what is Azure Kubernetes Service? Very simply, it's Microsoft's fully managed container orchestration platform. It's Kubernetes, as we might know and love, run and managed by Microsoft. Why do we want to use this? Because all the backend stuff, Microsoft takes care of us. It takes care of the API server, the scheduler, the controller manager, all those good stuff for us. And all we have to worry about as users, we have to worry about how many nodes we want, our pods and our containers, i.e. the bits that we deploy into that cluster. So that's what Microsoft is doing for us. Why do we want to use this? It's going to provide that full cluster management as well as the security around that environment for us. When should you start to use these types of things? Well, this is when you've got applications that have several dependencies on additional libraries. You can wrap them all up in a container as a service and deploy them into your Kubernetes cluster. It's very good if you have microservice architecture. Obviously, it's perfectly fit for that. Or you've had a large array of legacy applications that you wish to modernize. Kubernetes is a good fit for that as well. What we have also noticed is increasingly these days, the COTS vendors or the commercial off-the-shelf vendors, they are starting to supply their software not only as installable executables as we would normally install or binaries, but rather as containers. So we download the vendor's container and we deploy that container into our Kubernetes cluster, and all of a sudden we're able to run their software in that fashion. So Kubernetes is great in terms of component that we like to use in terms of this cloud native architecture. The next one is Azure Functions. So this is Lambda architecture. What is Azure Functions? This is the embodiment of serverless. So what serverless means is we don't worry about provisioning anything. It's not like we're provisioning a container or a pod or a node. It's not like we're provisioning a VM. Really, we're just telling Azure, here is a service I want you to run. So serverless code or serverless functions, the great thing about these guys is they allow us to scale down to 0, which means if no one's calling that function and running that bit of code, we're literally paying nothing because it's scaled all the way down to 0. And when someone wants to make that call, that thing is spun up, or that serverless function is spun up, and it responds to what it needs to do. These are fantastic for event-driven type solutions that we may want to build. And when do we use it? As I said, event-driven applications or low footprint applications. What we find, we do a lot of work in the integration space. Functions are fantastic if you've got a complex little bit of business logic that you may want to run as part of an integration flow. So for example, if I've got a complex conversion from one format to another format, I can code that up in a function, and that function only executes when it's needed as part of an integration flow, and I only pay for it for the time that it's actually running. So this is that microsecond billing option that we have. So that's Azure Functions. So in short, that's what we have available to us in terms of the Microsoft ecosystem. These two things I think are very important for us to consider. We're now going to crack on to the rest of the session, showing you guys some demonstrations about how all this technology fits together and hopefully provide you a better understanding about what cloud native and serverless can do for you in a scenario. So the scenario we have today that myself and Michael will be taking through, nice little picture of both of us there, is the rating solution. So in our fictitious company, we essentially have this idea that says we sell widgets or products, and we have a situation where we sell products to multiple different solutions. We have an e-commerce website or some kind of a website where people buy products. We have a mobile application where customers can use a mobile application to purchase and rate and engage products or services from us. We also have salespeople who have tablets who go door to door and create and purchase products. The challenge that we've identified, or has been identified by our C-suites in this specific example, is all these different solutions have different ratings components. So what happens is somebody rates on the mobile app, somebody rates on the website. There's a rating after the service has been formed on the tablet in the person's house. Now, all these different rating solutions. So the only way we can get a full view of our ratings is we then have to pull the data out of these source systems into some BI engine to do a nightly batch and a process. And once it's done that process, we now know information about our ratings, and we then finally able to update and say, this is the average rating for this service or this particular product. So that's the challenge we've got. So the solution we've come up with is we would like to break ratings out into a separate microservice that deals and focuses just with ratings. So what do we know about this? We know that we have many ratings are going to come at high volume. So our solution must be able to scale, because we're going to have peak and trough periods. So the traditional people are purchasing things over holiday. We must be able to have our solution automatically scale for that when we hit those high volume things. We need to be able to, every time a rating gets entered into the system, based on the values of that rating, we want to raise an event and potentially as many subscribers. So one of the subscribers we may have is we may want to recalculate the average every time a new rating, or maybe every 10 ratings is added, or recalculate the average for the product. But what we may also want to do is fire off a notification into our marketing team if somebody gives us a particularly bad rating. If they give us a rating of 1, we want to get the marketing team to get a hold of that person or that customer and resolve the fact that we've got a bad rating. We might also choose to send something off to our customer loyalty team. A different event has happened, a different action that says if somebody rates us 5, well, now what we need to do is add an extra point to that person's loyalty program. So this is really what that event type architecture could espouse. What do we need? We absolutely need to be able to scale fast and automatically, and we need a cost-effective solution. So what we don't want, in order to create this massive scalability, to create this separate little set of microservices, we don't want this to cost us an arm and leg. We should be able to really pay for what we use, and we should be able to make sure that we're able to manage that. Lastly, we want consistency and agility. What we don't want is to build a solution in an amazing way in our dev environment, and then when we get to production, everything falls apart, and then we as developers turn around and we say, well, it worked in my environment, it worked in my machine. We want to drive some consistency, and what we want to be able to do is improve that service very quickly. If there's new requirements that come in, we're able to build and release and run that accordingly. So that's what the aim of what we're trying to do is. This is what the architecture looks like in terms of the components we've put together for you today in a demonstration in Azure. So very quickly, I'll run through these and then we'll start the actual showing you what they look like. So what we're going to have is we're going to have a user working on a browser interacting with a Angular single page web application that's hosted in an Azure App Service. Remember, that's that PaaS, Platform as a Service that I spoke about. Then what's going to happen is that's going to call onto Azure API Manager. Azure API Manager is going to apply all of our non-functional requirements for us. So what it's essentially going to be doing for us, it's going to make sure that all of the APIs are correct, all of the calls that go through pass all of the compliance that we want. They're audited, they're logged, we've got caching happening, we've got authentication. API Manager is going to do that. Then what's going to happen is that call is going to go through to Kubernetes, where our actual service that deals with ratings lives. That service is going to be able to scale automatically based on load, and it's going to be pushing the results of the ratings into our cloud-native database called Cosmos DB, which is a NoSQL database. Once it's in that, we're then going to have a set of subscribers. So we can say, oh, we've got a new rating, put it onto an event grid, and we can have any number of subscribers subscribing to the event that a new rating has happened. That is then going to go fire off an Azure function in this particular one example as a subscriber who's going to recalculate the average and put it into some temporary storage so that all my client applications or client users have the opportunity to see what the new average rating on that product is when they pull and open that accordingly. The first bit we're going to focus on, however, is that's fantastic. How do we make all of that come into existence? And what we're going to show you is we're going to talk to you about how we can use pipelines in Azure DevOps with ARM templates to completely automate the entire deployment of all of these infrastructure components that will then ensure consistency. We're also going to have pipeline components that are responsible for actually deploying applications. And the example we're going to talk about is how we dynamically create the container and have it in Azure Container Registry to be automatically deployed into our Kubernetes cluster as and when it needs to scale or needs to be used. So that's me. I've spoken a lot. Michael, you want to go ahead and start that part of the demo?
Yes, thanks, Piers. Hi, everyone. Let me start by sharing my screen. I hope everyone can see my screen right now. So the first thing I would like to show you guys, I want to show the components in Azure that Piers outlined in his presentation. Here we can see the Azure API management, the Azure Kubernetes service, the Azure function, and so on and so forth. Now, to provision these components, the easiest way to do this would be through the portal by clicking the Add button and selecting which component, which platform, which infrastructure component I would like to provision. However, the challenge that comes with that we will need to repeat the same steps for each one of these components, and also we'll end up repeating all of these steps for every environment. The challenge that comes with that, it makes it really error prone as it includes a lot of manual steps, and also it consumes a lot of time and effort. And that's actually where the infrastructure as code concept comes into play. So infrastructure as code allows us to store the configuration for all these components in scripts stored and versioned in source control, and with some help from the DevOps pipelines, we can automate the whole deployment for these components to provision a whole environment from scratch. Let me show you an example. So if I go to my Visual Studio right here, I can see that I have on the right-hand side a whole bunch of ARM templates chained together for each one of these components we just saw in Azure. And what you will notice that we'll have for each one of these components two files. The main file, which includes the ARM template, the one we are seeing right now is for API management. And actually ARM stands for Azure Resource Manager. It's the way that Azure understands these files, and basically the configuration within these files, when it gets executed, Azure provisions the resource included or configured in the file. And what you will also see that we have another file called parameter file. Because we will end up deploying the same component to multiple environments, sometimes some values need to be changed between environments, such as name, location, and pricing.
So Michael, if I understand what you're saying, with this capability where I've got my code scripted as these ARM templates, I can use those parameter files between the different environments. So basically, I have the exact same definition of the components, and the parameter files just change the settings for the individual environments. Is that right?
That's correct. That's correct.
Okay.
All right. Now that we have seen the files stored and versioned in source control, the next step would be to explore how the DevOps pipelines can help us take these files and execute them and package them to provision a whole new environment in Azure. So if I go to my Azure DevOps tenant, you will see we have got a pipeline here called Azure Foundation.build. Now, the way we achieve these deployments in Azure DevOps is by having build and release pipelines. So if I try to check the first build pipeline we have, which is the Azure Foundation, I can see it's a very simple pipeline that only includes a couple of steps. The first one is around building the ARM templates. It's about building the Visual Studio project we're just seeing and making sure all the ARM templates are well formed. And the second one is publishing all these files into one single package to be ready for deployment. And now,
so Michael, if I understand, what we're basically saying is this build thing that we've got in our pipeline, his job is to take the code from our source control, build it, and make it ready for you to then essentially deploy that infrastructure for us. Is that right?
That's correct. And that's the job of the release pipeline, which we'll see in a minute. So if I click on releases, as you can see, we have a release called Azure Foundation.release. And I can see that the last successful release is release 37, and it was deployed to the environment called Demo. Now, in a real-world scenario, what you will see is all your environments next to each other, like dev, test, UAT, and production, so that you can see this release was deployed to which environment and which environments are still pending.
So, Michael, what that means is I can define, if I'm right, I can define my infrastructure with the ARM templates. I can build them, I can deploy them to an environment, and over here, I will then be able to see which version of my infrastructure is running on which environment.
That's correct. That's correct. And also you can see, for example, if the release has been deployed to dev and test and still pending on UAT because it's waiting for approval or because it's still being tested in the testing environment and so on and so forth.
Well, that's great. So we can put that governance workflow in to say, until the relevant CAD process is run and someone's actually approved it, it doesn't actually deploy that into production, for example.
That's right. Now, I actually want to dive a little bit within this release to see how the deployment looks like. So if you click on that one, you can see that we have multiple steps. And essentially what's happening, each one of these steps is deploying one of the components in our solution. We can see the first one deploys application insights, the second one deploys the storage account, the third one log analytics, so on and so forth. I also would love to show you guys a couple of things. So if I switch to the edit mode for this release pipeline, and if I select the first step, for instance, which is the one that deploys the application insights, what you will see that it's using the ARM templates we saw in the Visual Studio. The first one is the main ARM template, and the second one is the one including the parameter values. So another interesting setting we have here is called deployment mode. Setting this deployment mode to incremental is basically telling Azure Resource Manager, when you deploy this ARM template, if you find that the current resource is already provisioned, do not delete it and re-provision the whole resource from scratch. But what you would rather do is just make sure if there are any changes or updates in the ARM template, just apply these changes and updates and do not delete the existing resource.
So Michael, that's awesome. I think what that means, right, if I'm understanding, is the first time I code up my infrastructure and deploy it, I can deploy it all the way through to production with these parameters. If we then decide to make a change to my infrastructure, I guess something like moving one of the components up a tier, I can update that in the original file, make that change and redeploy the whole file. And Azure is smart enough with this incremental thing to only apply the change. It doesn't pull everything down and take them offline in order to make that update to the infrastructure. It just makes that one change.
Exactly right. Exactly right. There is another pipeline that I would love to explore quickly if we move again to the build pipelines. So what we have seen now is just build and release pipelines to provision the infrastructure resources or the platforms. We have got another build pipeline for our rating API. What's actually
Michael,
happening?
Just quickly, the one we saw first, that was the one that deploys the infrastructure. So that sets up all our Azure components. And
Yes.
this is the one that's responsible for deploying the actual application, correct?
Correct.
Awesome.
Yeah, so this build pipeline for the rating API is just creating a container image for our API, as we can see in the first step, and then publishing the image created, the container image created, to the Azure Container Registry to be used later by the release to create container in Kubernetes.
Awesome.
Yep. That's all regarding the build pipelines, build and release pipelines.
Awesome, Michael. Thank you very much, man. That's great.
Thank you.
Okay, so I'm just going to go through the summary of what we saw over there. So what we saw over there was obviously how we can use Azure DevOps to automatically deploy our entire infrastructure. We also had a quick understanding of how we can use Azure DevOps to actually deploy our application. The next thing in our demo is actually this idea that says, well, now we actually want the application to do something. So what we're going to show you now is how we have our browser-based application, single-page application, how that's going to make a call through our Azure API management. Remembering that API management, his job is essentially to do all the non-functional requirements, things like logging, auditing, security, throttling, so our developers never have to write that code. Expose that into my application, apply those policies, that non-functional requirements, and then call onto my Kubernetes cluster, where hopefully the application code is going to run. That application code will then scale automatically based on volumes that we have over here and push the final result set into Azure Cosmos DB. So Michael, you want to share a screen and show that, please?
Yes. All right. So the first thing I want to show here is the web application we have. Okay,
Oh,
and
we just can't see your screen, Michael.
Okay. I'll reshare. Can everyone see my screen now?
Yep, all good.
All right, great. So the first thing I want to show is the web application we have here, and it's running actually in App Service in Azure. And this web application will help us submit or add new ratings. Behind the scenes, it will be calling our API, which we'll just see in a minute. Let's start by trying to create or add a new rating. So I'll give the title as MOQ webinar. Customer name is MOQdigital. And set the description, webinar is going really good. And let's set the rating as 5 and click submit. I'll get a message that the rating has been successfully added. Now let me move to the API manager. So guys, this is our API management instance. And what you will notice on the left side, we have a particular API called rating. So what has actually happened when I clicked on the submit button, the application has called the API management and passed the rating data. And the API management endpoint received the data, executed all the policies, which we'll discuss in a minute. And once all the policies have executed successfully, the request was passed to the backend, which happens to be a container running in Kubernetes in our case. So if I quickly check the policies, there is one particular policy that I would like to show you guys, which is called rate limit by key. Now, what's the purpose behind leveraging that policy? So because my application or my rating API is going to be called by so many applications, by so many consumers, I want to make sure that each one of them gets its fair share. What I want to avoid actually is for one of these applications or for each one of these applications, I don't want any one of them to load my API and force my backend to scale unnecessarily. So what we have actually done here, for each one of these applications, we have set a maximum number of calls they can make to the API over the course of a 60-second period of time. If I click edit on this policy, you will see that the maximum number of calls allowed is 1,000 over the course of the 60-second period. For example, if an application is called Bob, Bob cannot call our API more than 1,000 times within a 60-second time frame.
So Michael, if I understand correct, what we're doing over here is we're applying one of these policies so the developer doesn't have to write that. Because in the old days, I would have had to somehow write that in my code to keep track of how many times I was called by a specific person and then to start to send them errors. It become quite difficult, right? So this particular policy, and I'm sure there's other policies as well, this particular one allows me just to limit throughput, right? So this is a rate limiting one.
Yeah, that's correct.
Cool.
That's correct. Yeah. it's also important to know that there are hundreds of policies in API management, and all of them are like this one. We don't need to write any code, and they are
just
all
apply
just we can just apply all of them in the portal without writing any code. Correct. The other thing I want to show you here, guys, is the developer portal. Now, the developer portal has been made actually for companies that have publicly exposed APIs. And since these APIs will be publicly exposed, there will be lots of developers consuming them. And usually these developers, they would like some place to show them how this API is being called, what does the schema look like, what the authentication mechanism being used. And that's what the developer portal is made for. So if I click on that one, you can see it's a very simple portal out of the box that comes with API management, and it shows everyone the APIs in your organization and how you can call them and what schema is required.
So Michael, what's great about this is if I'm coding these APIs, not just for internal, but even for external uses, I can essentially have this portal. And my understanding is external developers that are approved can come in, request access. We can give them access to the portal. They can read about how to call our APIs. They can even test that API and be routed onto backend test infrastructure. And then they can essentially become users of our component, right?
That's correct.
Cool. So what happens with those calls there, Michael? Once we've done all of that, it's gone from front end. Where does the code end up?
So once all the policies have executed successfully, API management passes the request to the backend, which happens to be a container in our case. So let me move to the Kubernetes dashboard and see our container, our rating API container. So what you will see over here, we have got a couple of pods, which are essentially containers running for the same application, which is the rating API. You can see the name is called MOQDemo API rating. And the reason we have two containers or two pods running for the same API is because we want to ensure high availability. At any point in time, there will always be container running to serve incoming traffic. And also on the right side, you can see the CPU and the memory consumed by each one of these containers.
Hey, Michael, I'll get a question for you. So how does the auto scaling work, or how can I make it scale up? How does that fit together?
Yeah, excellent question. So because like we were saying before, in holiday period of time, we can get a huge spike in the traffic, and Kubernetes is smart enough to scale the application. What will actually happen, Kubernetes usually check the threshold, which we can usually control for the CPU and memory consumption. And if our container reach the threshold, Kubernetes start provisioning additional pods to serve the incoming traffic. So instead of having just 2 pods, you will end up having 4 or 5. Okay. One of the most interesting feature about that, in a scale-up event like this, you can also define the maximum number of containers you can have. In our case, if I show you the configuration on the next tab, you will see, it's not showing, unfortunately. So what we have done here is that the maximum number of containers during a scale-up is limited to 5. So that will be the maximum number Kubernetes can scale up to.
So I have the ability with that auto scaling in Azure Kubernetes, I can say, scale up when you need to scale up. This is the most you can scale up. And when you're done, automatically scale yourself down to a minimum of 2. So at least I've always got 2 running. Is that right?
That's right. Correct.
Cool. Where does the data end up, Michael?
Yeah, so we are using Azure Cosmos DB to store our data. So if I move to our Cosmos DB and click refresh on the collection we're using, you will see the rating we just added for MOQdigital. And if I click on the record, I will see all the data we have passed through the portal: customer name, description, satisfaction rate, and title.
Cool. So this is living inside of that Cosmos DB sort of serverless cloud data platform that geographically scales. I get a question for you, Michael. That data looks weird to me. So that's not rows and columns. Can you quickly touch on that?
Yeah. So Cosmos DB is the NoSQL offering in Azure. And the reason we have decided to use the NoSQL for our case is because it's very efficient in handling large volumes of data at a very high speed. And also because we understand that our API has a dynamic nature, the requirement for it can change at any point in time. We can add properties, remove properties. We want to use an unstructured mechanism for our API to store the data.
So in short, what that means is if we decided in one of our applications to add a couple of extra fields to rating, we can make a small date to the API, and the database platform would automatically understand that and allow that sort of schemeless change, so we could then have those additional ratings come in without having to even make any changes in the database. Yeah, is that right?
Yep, that's correct.
That's awesome. Correct. Okay, so in the interest of time, we're just going to switch on to the next little bit of a summary. Okay, so what Michael showed you over there was everything that happens from going from the web application to our API manager, which applied those policies into Kubernetes. We explained how Kubernetes would automatically scale based on volumes, and then we showed the data jumping into Cosmos DB. The next part of the demo we want to show you is this idea of event-driven programming. So now our ratings are successfully in the database. We're going to have an Azure function, which is our serverless model, pick it up and tell Event Grid, which is a hyperscale event processing platform, hey, a new rating has been added. We could have any number of subscribers. Michael's then going to show you the subscriber that has a responsibility of recalculating the average, storing in table storage as a cache, and making it back available to any of our applications that are using that front end. I'm going to go ahead, Michael, and demo that piece.
Sure. All right. Can everyone see my screen? I want to start by talking about the Azure function we have here called Cosmos Trigger. So the job of this function is basically to be called by Cosmos DB every time a new rating is added, and Cosmos DB is going to pass the record details to this function. And what this function will do, it will publish a new event that indicating that a new rating has been added to the event grid, which you will see in a bit. So now if I go to my event grid, I will see that we have a topic called Cosmos DB rating events. You can think of a topic like an event hub. It's a hub that receives a specific type of events. And in our case, the event we are actually interested in is a new rating being added to our Cosmos DB.
So if I understand, Michael, this whole topic hub thing, what we're basically saying is Event Grid has been told you are going to listen out for a particular type of event that says there's a new rating, and that function before is the one that says here's a new rating. Is that right?
That's right. That's right. Moving down, you can see a dashboard showing the incoming events over the last hour. We can see a spike here, and this is just indicating the events we just submitted through the portal. Further down, I can see the subscribers to these events. Now, the one I'm really interested to show you here is the second subscriber, which happens to be an Azure function. So if I click on that one, you will see we have an Azure function called Event Grid Trigger. So what actually is going to happen every time a new rating is added to the Cosmos DB, this function called Event Grid Trigger will be running. So the job of this function is essentially to calculate the new rating, the new average rating, since a new rating has been added, and store it in table storage. Now, if I move to this Azure function and click refresh to see the last successful run, I will see that this one was just it's not displayed for some reason. If I click refresh, yeah, so we can see that it is in UTC, but this just happened a few minutes ago. So if I click on the last successful run, I can see that the Cosmos DB average rating is now 3.8.
So Michael, to summarize quickly,
yeah,
that function received that event or got told about that event from Cosmos, it ran and it recalculated the whole average and has put it in cache, right?
Correct. Cool. And also the thing is, if we move to our application again right now, we should see that the average rating is updated to 3.8. So let me go to our application, hit the refresh button, and we will see that the average rating has been updated to 3.8.
Awesome. So the great thing about this, I think, Michael, is that this thing can scale almost infinitely, right? So we can have as many ratings as you want coming through. The entire architecture is going to scale accordingly, and we're able to deal with that load in this fashion.
That's correct.
Awesome.
There is a question I usually get asked a lot, Piers. So
okay, let me ask that question, Michael.
Okay.
Thanks for the prompt. Hey, Michael, how is it possible if I wanted to see, I've got all this kind of loosely coupled architecture, all these events firing, all this stuff happening. Is there any way I can see kind of the flow of traffic and how everything sort of fits together? I mean, obviously I've done some nice little PowerPoint thing that shows the people on the call, but what can Azure do for me there?
Yeah, that's an excellent question. So the way we track the message and the events flowing through multiple components in Azure is through Application Insights. And Application Insight has a fantastic feature called Application Map. Application Map, as you can see on our screen, it shows you all the components in your solution and the traffic going and coming between them. So if
that's awesome.
If we check the first one here on the left, that's the API management, and it's indicating that a call came in and only took 12 milliseconds to execute. If I move up here, this is the Azure functions we have in our solution. And as we can see, these Azure functions are talking to Cosmos DB, to the table storage, and to the event grid. Okay.
That's awesome,
Yeah.
Michael. I think that's it, mate. We want to give a little bit of time for questions.
Cool. Thank you.
So just in quick summary of what you all saw. Thanks, Michael. That's fantastic. So a summary of what you saw and hopefully you take away from this is the first thing is, guys, everything can be automated. What we're talking about is we can not just only automate the application CI/CD, deploy the code automatically, developer style. All the infrastructure can be written as code and deployed automatically and versioned into our multiple environments. And more importantly, we can do those updates consistently. Containers, fantastic technology for hosting microservices that need to scale. Serverless, i.e. Azure functions, they allow us to scale all the way down to 0, and they're fantastic for that kind of event-driven architecture that I spoke about. And then, importantly, we have these options to modernize by re-architecting. We don't imagine you're going to take your existing potential monolithic application and throw it into this architecture. It'll be a bit of a piecemeal approach. You'll certainly start to modernize some components, maybe start to use Azure SQL PaaS database, maybe start to host your application in application services, PaaS services. And lastly, cloud native and service computing costs less to run and manage. So beyond all the awesome innovative stuff, when you're running cloud native and serverless, the operating costs, not just the Azure costs, but even your own operating costs are reduced. So there's certainly good reasons to go that route. Quick thing before we get to questions, some quick next steps. Very happy for you guys to book a review session with myself or Michael or one of the other architects in our team. We'll come in, have a look at your application and state and help give you some advice about how you could potentially modernize that in Azure. Or if you're thinking of building a cloud native application, we're happy to spend some time with you looking at your architecture and providing some insights to that. We have some upcoming events. We've got a .NET modernization event, a half-day workshop. All of this will be sent to you guys after the call with dates. We also have 2 ebooks, an app modernization ebook we've written, and we're about to release our own ebook on best practices for Azure Kubernetes, which will come out the next week or so. Please reach out for any assistance if you need anything. Kayla, do you just want to go to the questions if there's any?
Yeah, there has been a few come through.
Cool.
So the first one is, does AKS work well for stateful apps, or is it recommended only for stateless apps?
Mark, you want to take that one? Michael?
Yep, sure. Yeah, that's an excellent question, actually. No, AKS actually can do well for stateful apps as well. Containers in nature are stateless, but nevertheless, AKS caters for stateful applications by leveraging features such as disks and stateful sets as well. So it can definitely cater for both types, stateless and stateful as well.
Awesome.
Awesome. And the second question is to see, excuse me, to see end-to-end application maps, do you need to have all your services integrated with one application insights account?
That's correct. All the services and all the components in the solution, they need to be connected to the same application insights instance.
Which kind of makes sense, right? You want to actually pull them together into one place. I guess that depends ultimately on the overall architecture. So if you've got different teams responsible and you do have that line of segregation, you could have 2, but from the application insights map, they have to be inside of the same instance in terms of actually tagging and making sure we can follow that flow of traffic. Any other questions? Do I take that as a no, Kayla? The no, the
yeah,
questions?
That's it. We're all
Awesome.
good for questions.
This must be the first webinar we finished 2 minutes early. I'm amazed. Well done, Michael. So guys, yeah, really, hopefully you've enjoyed the presentation and the session. We've tried to pitch it at a technical and a bit of a business level up front. We're happy to help you guys with any further queries or questions you have. If you want to go down this route a bit more with us, happy to have myself or Michael, one of the other team, come and sit with you and work out what that journey to modernization may be. We've got Microsoft on the call as well. Happy to involve the Microsoft team as part of that discussion and journey as may be required, and see if we can help you get your first step into this new world of either building greenfield serverless and cloud native, or modernizing your existing applications in a roadmap towards this technology stack. Thanks for the time.
Thanks, everyone.
Thanks, everyone. Thanks, Piers.